Hello everyone, I put together this quick video because I want to sort of give you an orientation to both Anaconda and Spider and then show you a script that I put together. It's the same kind of script that I want you to put together as your first sort of step out into kind of the real sort of Python world outside of data camp. So first thing I'll do is I'll give you an overview of Anaconda Navigator, and I'll show you how to get to Spider. I used Spider for my script simply because that's just what I chose. One of the videos that I'm going to have you look at, the one after this, he uses Jupyter notebooks. You're free to use whichever you like. Let's first of all start off by, once we have actually taken a look at, or downloaded Anaconda, let's take a look at what that looks like. In my case, I've got this folder here, and it's giving me all these applications, and there's Jupyter, there's IPython, there's Spider, there's all these things here. And the one I want you to look at is Anaconda Navigator. So if you pull that up, that's going to bring up Anaconda Navigator, and actually I already have it up, so I'm kind of duplicating some work here. And you'll see all the different applications that are available under Anaconda. And there's Jupyter Notebook, which is what he uses in his video, and I'm using the term he because I think his name is Keith, but I've forgotten his name. Anyway, but I'm going to have you look through his video first, or after this one. And then Spider is what I used, and Spider is an editor. It's basically an editor. It's a Python editor. It is a little bit more like what you have, what you were looking at when you were in data camp. And it looks like this. When you select it, launch it, it just simply looks like this. And over on the left-hand side is where you can write your script. And you can write your code right there, and document it, of course, very carefully. And that's where you will actually produce your script. When you're done with your script, you, of course, would come up here to File, and you would save your script, and you would give it a .py extension to remember what you called it. Okay? Then over here on the left-hand side, we've split the screen into two parts. One of which will allow you, it's kind of cool, it's kind of a little bit like RStudio, for you guys who used RStudio last quarter. We have the ability to look at different files that we have available to us, and we also have Variable Explorer. So when you load a file, or you load a variable, or you populate a variable, it'll list it there. You'll be able to see kind of which variables are available, which ones are open, which files have you loaded, that kind of thing, which is really useful and helpful. Then this screen down here is where you can actually type in real kind of Python commands. So I could do 3 + 3, and it'll immediately give me the result, right? So over on the left-hand side is really an editor. It's not going to run anything until you tell it you want to run something. But over on the lower right-hand side, that's really just kind of your console. You can run any command, you can try anything out. And then if you're unsure about whether or not your command is actually set up correctly, you can test it out in the lower right-hand corner and see if it works. Okay. So one of the things I'm going to have you do in the next video is actually load a file. And he's given us a sample file. It's a Pokemon file. I don't know anything about Pokemon. I know people are interested in Pokemon. People play games on their phones, whatever. I just chose it because it was available. So I have no real attachment to it. But what I'll have you do is work with that file and do some of the stuff he's going to have you do with that file, because it gives you a real chance to sort of get your hands dirty, learn from your mistakes, load up a data file, and start playing around with it. The first thing we're going to have to do, though, however, as we get ready to do this, is we're going to have to make sure, just like we did in R, we're going to have to make sure that we can get access to the data file. So the data file has to be available to us in a working directory. And just like in R, we had to set our working directory. Now, in RStudio, it was easy to find your data files. In even R, if you just use the file.choose option, it became fairly easy. I'm not going to give you the easy way to do it here because I want you to get familiar with how to really do it. And it's the same way he does it in the video. So we're going to have to check our working directory, and then we're going to have to change our working directory. So in R, there's packages. In Python, we have libraries, and we have to import those libraries. And one of the libraries that allows us to check working directory and change working directory is a library called OS. So in order to be able to use that, we're going to have to import that. If we don't do that, then our change working directory and check working directory won't work. Okay, so we'll go ahead and import. Actually, I can do that down, that's fine. OS, and it is imported that OS. So you can see I'm in the lower left quadrant there. Okay, the command to look at our current working directory is get current working directory. So it's get cwd. But we also have to say that we are using that section of the OS library. So we have to specify OS, and we're going to do this a lot. We're going to specify the main library that it comes from, separate it with a period, and then we're going to tell it the command that we actually want it to use. In this case, is get current working directory. open paren, close paren. Looks similar kind of to what we did in R, but in R we didn't have to precede it with the package name. Here we have to precede it with the library name. And it tells us, tells me that my directory, my current working directory is users cert D. Well, I actually need that to be in my, my documents directory. So I'm going to have to change my working directory. Let me take a quick look. Let's fix that. Okay, so for me to be able to actually change the directory, it will be scdir, change directory. And I'm going to have to specify in my parens and single quotes. We use a lot of single quotes in Python, as you probably have already determined. Backslash users, double backslash qrtd, and then the documents directory, single quote, double paren, done, change. So if I go back, 2 up arrows, I can use up arrows in this section of the Spider application, and it shows me that I've actually successfully changed my working directory. As you know, this is important, so if we're going to be able to actually access files, we have to have the files in the right spot, and we have to be able to upload those when it comes time to actually load up those files. So there's 2 ways to do this, of course. You could have just as easily taken the file. I could take in the file, the get data, or the Pokemon data file, and put it into the current working directory, which is just my own name under users. That would have solved the problem. Or I could just change my working directory. But I just wanted to show you how you can use the OS get current working directory to show you the working directory, which is very similar to what we did in R, and then do the OS change directory, which was the set working directory, similar to set working directory, what we did also in R. Now I'm going to go ahead and pull up the script that I created, and this is the script that I want you actually to create. I want you to walk through as much of the script as I did. It's about the first 20 minutes of a really great video that uses that shows you how to use a particular package called Pandas. And we're going to use Pandas because Pandas is really set up for a lot of data science functions. But what I want you to do in this particular video is just to get familiar with it. So I'm going to go ahead and open the script, and I called it PDAS because it would be easy to find. And now I have to find it. So if we're going to Explorer, there's my script. And here is kind of the whole thing all sort of filled out and done up to the point where I want you to work through. The script that you'll work with, he walks you through every one of these. The challenge is he goes really fast, and so you're going to have to stop the video a lot just to catch up, make sure that you get the commands put in correctly. First thing we have to do, though, is we have to import the Pandas library. And when we're importing the Pandas library, which I'm sure you saw him do this in Data Camp, we're importing the library itself, and then we're just giving it a different name. So we're going to import Pandas, and we're going to give it PD. So that's just simplification, right? So we don't have to type in Pandas the whole time. We just type in PD. Down here, we're creating a data frame. And the data frame is the simplest name we could possibly give it, DF, which probably is not the best idea because you're going to forget what it is maybe later on. But DF, we're going to set that equal to PD PD.read_CSV. Let's talk about what that command is doing. Okay, we are actually going to read in a file using the read CSV. That's very similar to what we were doing in R. But in this case, the read.csv is part of the Pandas library. And so we have to specify, first of all, the library that we're using, which we're using kind of a substitute name. The PD is a substitute name for Pandas. And then we do the .read CSV. This is very similar to what we did with the OS on change working directory and get working directory. We have to specify the library first. So in all cases where we're actually doing one of the columns that is part of the Pandas package, we have to specify the PD first. Okay? So we're going to set the data frame df equal to the result of library, first of all, which is PD, and then that is followed by read CSV, which is a function that reads in a CSV file. The problem is that the name that I have given my file is different than the name that is actually in my directory. So I'm going to have to change this. I was playing around with it earlier, so I'm going to go ahead and change this. Pokemon data, that's the actual name of the file. And when I run that, I can see if it loads the file. Now there's 2 ways I can run it. I can either capture it here and drop it down into the console, and I can run it there and see if that works. Or There's a number of icons at the top here that allow me to run either the whole script or run from certain sections. For this icon right here just runs the current line. So I can do that and run the current line, and it is not going to work. And it's not going to work. Why? Because I forgot to do this up here. I didn't run that line. So I haven't even imported the pandas and set it as PD yet. I got to do that first. Okay, that worked fine. Now we'll go to the next one. And it did not load the file. Let me find out why. I'll get back to you. Okay, so my first load didn't work, so we're going to try it again because I think I finally correctly moved the file to the right directory. So go ahead and hit that, and it has loaded the file. Okay, a couple reasons why I know it's loaded the file. First of all, it's going to throw me a giant error, and it'll throw you this giant error if it can't find the file. And the reason why it couldn't find the file is because I had it in a directory. Windows 10 does funky things with files. It needed it to be in the OneDrive directory. I fixed that. That's fine. Okay. So it didn't throw me an error, and it also shows me up here in my variable explorer, it shows me that I have a data frame that I have loaded, and it tells me how big it is and all of the stuff that's in it. So great, I'm off to the races because I have a data frame loaded. Okay, next thing we're going to do is we're going to take a look at the head and the tail of the data frame. Just like we had tail and head in R, we have similar commands in Pandas in Python. And so what we'll do is we'll use the print command. We print a lot of things in Python, and we'll print out to the screen. Again, we're going to use the data frame, df, and we're going to print the head of it. And we're going to print the first 3 rows, and then we'll also print the last 3 rows. So we'll print df, and we'll print the tail of it, and print the last 3 rows. Let's go ahead and run those. There's my header, and there's my tail. Okay. What if I wanted to know what the columns were? So there is a function here that will allow me to print in my data frame all of the columns. And it gives me an abbreviation of them, right? Actually, no, in this case it gives me all of them, so I see all of them. But there are 12 columns, and it tells me what they all are, okay? So those are my column names, and now I can print the contents of a single column, okay? So I can read all of the rows and print all of the rows for that particular column. And the second column is called name. So I want to see all of the results for name. Now the problem is that my data frame is 800 records long, more than 800 records long. So it's probably going to give me an abbreviated presentation of those. And there they are, right? Now, did it abbreviate? Yes, it did. It got up to 29 with RBOC, and then it said, okay, I'm going to skip ahead all the way to 770. And so you'll be able to see, I'll print you all the way out to actually it's 800 rows exactly. I'll print you all the way up to 799, counting row 0. Row 0 is actually row 1. So we have a full 800 rows. It tells me what the names are, okay? So I know that that function has worked, and I can see kind of what's in that column, sort of. If I want to see them all, I have to, of course, change the command, but we're not going to worry about that right now, okay? The next thing we want to do is we want to look at specific rows, okay? And there's the iloc function. The iloc function is the integer locator. And the integer locator, what the integer locator does is it locates specific things that I want to look at. In this particular case, I'm going to look at iloc 1. Okay, so iloc 1 is integer locator 1, and it's going to give me a specific row. Let's go there and take a look at that. And it tells me what's in that particular row. So you know that there are 12 columns. There are 800 rows. This is actually row number 2. Remember, everything starts at a count of 0 in Python. So if I wanted the first row, I would have had to tell it, give me row number 0. In this case, I told it to give me row number 1, which is the second row, so it's giving me the name and all the other different information about that particular record. Okay. Now, what if I wanted to look at, do an integer locator on the first 5 rows? I can do that as well. And it gives me, again, abbreviated, in this particular case, columns. Now, if I wasn't dumping this out to the console and I wanted to dump it into a file or a variable, then, of course, it's not going to abbreviate it. It's going to put everything into that file or that variable. But in this case, it's just doing it kind of just so that I can see it and manage it a little better. It's giving me the abbreviated version. So whenever you see the ... you know that there's a big section that's been cut out of the middle. Okay. So now what we're going to do is we're going to read a specific location. And this is very similar to R. R does this in a very similar way. Okay. So what we're going to do is we're going to look at the second row and we're going to look at the first, but that's not right, is it? No, it's the third row, because remember, everything starts with 0. And instead of it being the first column, it's going to be the second column. The second column we happen to know is name, right? Because name, the first column is a hashtag. It's just a locator. It's a number, basically a row number. And the second column indicated by a 1, is the name of that particular record. Okay, but we're going to do this for the third row. So what is this going to bring back? It's going to bring back the particular name in that third row. And there it is. Okay, Venusaur. Okay, so now we're going to look at an opportunity for us to parse through each row. And what this would do is this would produce an output that's going to show us every single row, and we can sort of kind of wind through it, look through it, and see what it is we want to see. Okay, so we'll go ahead and run that. And it's going to say for index, where row in df is interrows, print that particular index in that particular row. So basically, until you run out of indices, you're starting at 0 and going to 799 for all 800 of them, print me out this row, and print me out all of the contents that are in that row. We do that, and it gives us a whole lot of output. Okay, and the very last record we have is 799 indicated here. That's the hashtag, and we got the file, the name, and all that other stuff. And if we scroll back through, we'll see them all. Okay, but what if we just want to see part of that output? In this particular case, we'd like to instead see just the names. So instead of saying, you know, for all indices, print out of the 800, print out everything, we're going to print out the index and we're going to print out the row, but we're also going to specify in single quotes, we're going to set the name. That's the name, it's the actual second column in. So we'll go ahead and run through that, and it gives us all of our names. Okay, and we can see all the name records. And in this case, it doesn't abbreviate, it just gives us all of them. Okay. That way we can get through whatever particular field we want to look at. We can see it's similar to like when we're viewing, and if we were to view and say, give me a view of columns 1 and 5 in R, we could see something similar to that. Okay. So now we want to see all rows where, in this particular case, the type 1 column is set equal to fire. And the double equal sign means basically equals exactly. And this df.loc is allowing us to use our data frame. And we're going to do a df.loc, allows us to identify particular fields that meet certain conditions. So we specify within the square brackets, once again, the data frame. And the data frame, what we're really looking for is we're looking for the type 1 column. The type 1 column there is in single quotes in the square brackets. And using the double equal sign, we're saying it is set exactly to fire. And so when we do that, it will give us the opportunity to see all the ones where type 1 column is set equal to fire. And there they are, right? So there's a conditional that will return all the fields in that particular case where that type 1 is set to fire. Okay? And then the last thing we're going to do in this particular script is we're going to do some summary statistics. In this particular case, we'll do df describe, and it will give us what essentially turns out to be not terribly meaningful summary statistics, but it shows the count for each one of the columns. See, we've got our columns there. We have information about count, mean, standard deviation, minimum 25, 50%, 75, and max. So it's kind of similar to what we did in a couple of cases when we were looking at R and we wanted to do summary statistics in R. Okay. And then the last thing we can do is we can sort our fields. In this particular case, we can sort by name. So this df, again, is our data frame, and then the function we're going to apply to it that comes from the Pandas package is going to be sort underscore values, and we're going to sort by name. And if we do that, we get our rows, 800 rows, and they're sorted by name, and you see that Z's are at the end, and you'll see that the A's are at the top. Okay. That's about as far as I want you to go with this. We'll probably continue to fill up and finish out the script or the video, the second video, with more functions, because I think it's a really good overview of the functionality that's available in Pandas. And then next week we'll look at visualizations and take a look at some opportunities to go through and do graphs and plots and the like. Kind of similar to what we did in R about this point in the course last quarter. Okay, so go ahead and couple things. First of all, make sure that you have downloaded Pandas. Make sure you've downloaded Anaconda. Okay, and once you start with Anaconda, go ahead and play around with it, bring it up. You can use Spider, which is what I've used here, or you can use a Jupyter Notebook, which is what the host of the video uses, and just follow along. See what he's doing and get your hands dirty a little bit. I think the biggest challenge for you might be, and he doesn't go over this, so pay attention to this at the beginning of my video, setting your working directory and making sure your data file is in your working directory, because you see what happens when the data file is not in the working directory. It gives you a really horrible error. But that's with the the OS package. You're going to have to import the OS package, and then you're going to have to use OS set current working directory and change directory in order to be able to make sure that your data file is in the right place when you get ready to load it. You have a copy of the Pokemon file. I've already provided it to you, and so you should be off to the races. And just go ahead and run through this, get familiar with it, and if you have any problems, let me know. Okay?